everyone, welcome to the Impact Webinar 2025 Check-in, Driving New Hydrogen Economy in Europe. I am Cecily and I work as a content producer at Leader Associates. It is my great honor to host this webinar today. As Europe advances towards its decarbonization goals, clean hydrogen plays a key role in building a sustainable energy future. This webinar offers a timely check-in, focusing on the progress and next steps for Europe's hydrogen economy. It brings together industry leaders to discuss new policy directions, industrial applications, and regional partnerships, scaling up the hydrogen economy. The insights of investment landscape that are shaping the hydrogen adoption. Attendees will gain a clear understanding of Europe's hydrogen journey. Join us to explore how hydrogen is transforming Europe's energy system and what lies ahead on the road to a sustainable future. This webinar is also part of the digital content for Connecting Hydrogen Europe 2025, Europe's leading and most influential hydrogen event held in Madrid, Spain, on June 18th to 19th, 2025. CHE 2025 will be the fourth and the largest edition in the event's history. It serves as a premier platform that unites over 6,000 attendees from Europe and all around the world. The event provides a unique opportunity for partnerships and innovation, featuring 200+ speakers and more than 100 exhibitors. Now, I'm pleased to hand the floor over to our opening speaker, Mr. Murray Douglas, the Vice President, Hydrogen Research from Wood Mackenzie, to present his insights and an overlook of European hydrogen. Welcome, Mr. Douglas.
Thanks very much. Hopefully I am coming through okay. So if you just bear with me one moment, I will share my screen. And look, for maybe if I can just start off briefly, for those that are unfamiliar with Wood Mackenzie, we provide energy and resource analysis across the entire value chain. So within the hydrogen team, we have a growing team of analysts spread globally, covering that full value chain and leveraging the different areas of expertise that we have at Wood Mackenzie, whether that be across the steel sector, refining, road transport, aviation, maritime, gas, CCUS, etc. And that's really what we'll draw on during today's presentation. So what I wanted to do was really just provide a fairly high-level overview of some of the things how we're seeing the European market evolve, and some of the things that we're watching out for. So what I'll do is I want to start with something pretty basic. You've probably all seen something similar to this before in terms of how that announced capacity is coming through into the market. We still think that it's important to remind ourselves just how quickly things have developed, more so from that very early stage of just before 2020, when we started to really see that announced capacity build very rapidly in the space of just a few years. We can also see, we've just colored this differently to show how Europe stacked up in those earlier years. So it was very much a first mover in this regard. But then since then, all of the announced capacity growth has really been dominated by the rest of the world. Although we should caveat that many of those, a lot of that announced capacity growth has come from what we term gigascale projects, right? So projects that are, certainly beyond a sort of 2030 time horizon, and in many cases maybe lacking some credibility and might not end up materializing. So we have Europe just shy of 1/4 of that announced capacity, and we can see on a global basis as well, very heavily weighted towards green hydrogen capacity, and it's a similar story if we were to look at that from the European perspective only. What, of course, though, has been really catching the headlines this year is the number of project cancellations that we're seeing. Now, I think to some extent that there's not a huge surprise here that we are seeing projects cancelled. We saw a lot of early announcements coming through. So, there was always an expectation that we'd begin to see some attrition from that. Obviously, what's more worrying is that some of those particular projects that have been cancelled, and the classic example is the Ørsted Flagship 1 project, which had of course taken a final investment decision and was subsequently cancelled for a variety of reasons, but we think principally because they had not secured an off-taker. And we're beginning to see more project cancellations come through. We think we'll continue to see that next year. Again, maybe a more bearish sentiment for European markets there is that of that 2.5 million tons per annum globally that we've seen cancelled, almost half of that has come out of the European market. So we are seeing clear evidence of projects struggling in the European market. Now it's down to a number of different reasons. Some of those are as simple as, portfolio streamlining within companies where they announced a range of projects and they're simply narrowing down and focusing on the strongest opportunities, natural and evident across most parts of the energy value chain as well. It's not a particular problem for hydrogen. There's the obvious points around cost escalation, again, a common challenge across the energy industry just now. I think probably the ones that are more specific to hydrogen is this, inadequate policy support in some cases and the lack of regulatory clarity, which is certainly holding up some projects. So maybe causing less cancellations, but certainly more in the way of quite severe delays into these. And I think what we shouldn't also forget is that there is insufficient market maturity, particularly some of the project cancellations have centered on the e-fuel space. And whilst we believe that long term, the opportunity for e-fuels is strong, it's a bit early. That market isn't quite there yet in most cases. But the main point is this lack of binding offtake agreement. And we'll come back to that in a few slides' time. But what I wanted to do is try and move to a more positive story, right? So we have got 5.5 million tons per annum of capacity that has reached a final investment decision globally. Maybe slightly more negative, only less than 1 million tons per annum of that, or 14% of that has come from the European market. But nonetheless, that is a pretty positive signal. And to put that into context, that's around 6% of the current carbon-intensive hydrogen supply into the market. So considering that this is we're still in a very nascent industry, the fact that we've captured 6% of carbon-intensive supply to low carbon already is definitely a positive signpost. Oh, I'm just trying to, yeah, there we go. And what we can see as well is that counter to that initial chart on announced capacity, there's a heavier weighting towards the blue capacity, mostly because there is a lower cost profile on the blue side, and we've seen some large projects take FID, particularly out of North America. I think the other thing that strikes you from this chart is that the projects that have taken an investment decision so far are really concentrated in relatively few markets. And you can see that, certainly Canada, the US, and China are really driving forward that level of capacity that's actually managed to reach a positive investment decision. I think what's also interesting is if we just look at where that capacity that's taking FID, what end-use sectors it's targeting. So unsurprisingly, the refining sector is the leader in this sense. And in particular, you can see in the European space, almost half of that capacity that's taken FID in Europe is targeting the refinery sector. That's where there's just a much stronger investment case, and it's an easier decision for some of these, particularly some of the large energy majors, to make when you stack together all of the policy support that's in place for that. And then what we've also done here is just circle out the ammonia and export ones, because ultimately all of that export capacity is ammonia. But importantly as well, a lot of that export capacity will be looking to target the European market. And I'll come back to that towards the end, because I want to explain something that like a trend that we see developing around how ammonia exports to the European market might reshape the European market as well. But before I do that, I just wanted to touch briefly on where we're seeing the offtake agreements actually being signed. So we've seen positive momentum in the growth of offtake agreements. We track everything from non-binding term sheets right the way through to a binding sales and purchase agreement. We can see that the binding agreements are still lagging behind in terms of where we need to see those growing to support further FIDs into the future. But I think also when we look at this on a regional basis on the right-hand side, we see some quite interesting trends where we have, generally a heavier weighting towards green electrolytic hydrogen within most markets, with the exception of North America. And actually, one of the things that we're expecting, particularly under the new Trump administration, is we'll probably see that share of blue offtake agreements out of the North American markets continue to build and even maybe grow further over the next few years. What's the interesting point that we've been looking at more closely recently is that when we begin to put together these project investment decisions, the FIDs, and the offtake agreements that we're tracking, there is a bit of a mismatch here in terms of not all of those projects that have reached an investment decision have yet got a firm offtake agreement in place. And so what we're showing here is a breakdown of the uncontracted capacity from those projects that have reached FID. And we've just grouped this by the country of origin for each of those supply projects that's reached an FID. Now, there's a few caveats to make here that, some of these projects will have captive agreements. I think particularly in China, and that's why we've shaded it this way. It's maybe quite difficult to track all of those offtake agreements that are coming through in the Chinese market from the projects that have reached an investment decision. But what we can also see is that there is quite a lot of uncontracted capacity, particularly around the US. And what we've also done is just dropped a few company logos on top of this, because there are less than a handful of companies that are responsible for about 80% of that uncontracted capacity. But what you can also recognize from those is that most of those companies have quite developed value chains particularly into the ammonia markets and the hydrogen market. So they have got some ability to absorb this uncontracted volume. But nevertheless, we are seeing some pressure placed on those, particularly Air Products, from some activist shareholders who are highlighting this concern with uncontracted capacity on large capital investments. We think that this begins to become unwound through time, particularly maybe some of those Japanese auctions that we'll expect to see some results starting next month, and that will begin to reduce. We would expect some of that uncontracted blue hydrogen capacity, but it's certainly something that we're watching very closely over the next few months. Now, I'm not going to go through all of these in the interest of time, but it's just to again highlight some of the challenges around getting some of these contracts through. Maybe a couple that I would highlight is that alignment with auctions is always a challenge. So, a lot of these projects are trying to bid into auctions, whether those were the South Korean ones or the upcoming Japanese ones, trying to align the offtake agreement with the auction timing, and then also trying to take FID on the project poses some challenges. What we are seeing a lot of, particularly in the European market, is actually just some of the challenges around the tenor, the length of offtake contracts. So, while some of the buyers might be willing to sign up for 2, 3, 4-year agreements, some of the project developers really require agreements that are kind of closer to 10 years in length, and that's again beginning to hold back some FIDs. And I think the final point, we shouldn't forget as well that there's a lot of risk on the off-taker side as well. So some of these off-takers, particularly in the European market, that require some RFNBO compliant hydrogen, they are then exposed to the single supplier that they have lined up. So they need a means of backing up that green supply from somewhere else in the event that that supplier doesn't deliver. And that's also causing a bit of stagnation on the offtake side. And one of the ways that we think that gets unwound and why we're seeing quite strong progress in this area is through the ammonia market, because that, we expect some liquidity to develop in the ammonia market. So if I'm an off-taker of RFNBO compliant hydrogen ammonia, if my supplier does fail to deliver, there is perhaps an opportunity to capture some RFNBO ammonia from somewhere else in the market. And so that brings us to the final quick section that I'll go through, is that Europe has set goals around RFNBO compliant ammonia into existing industries. All we're really pointing to here is that there's a lot of uncertainty over how close the member states come to some of the targets that the European market, that the European Commission has set. And so on the right-hand side, I'll keep this brief, just to kind of give you a sense of how uncertain that level is, depending on how member states transpose that into their own legislation, and depending on how supply globally develops, it's fair to say there's just quite a lot of uncertainty over how much RFNBO ammonia is landed into the European market, whether domestically or through imports. And so then that just brings us to this final slide where we've been looking at, and we're showing here a simplified cost curve. So on the x-axis, you can see for non-RFNBO ammonia, so blue and gray, how much of that might come into the European market, and then on the y-axis, the clearing price of those volumes. And what we can begin to see is that conventional ammonia delivered cost would be exposed to a carbon cost, either through the removal of free allowances on the ETS or the implementation of CBAM. But either way, regardless of where we end up with on the demand range for RFNBO, we think clearing prices probably sit somewhere between $650 and $700 per tonne. However, when we then begin to look at that RFNBO ammonia cost curve into the European market, we can see far more shape here around where prices might end up clearing. And so if Europe does end up needing to bring in more RFNBO compliant ammonia, we would definitely come up to prices north of $1,200 per tonne. But if it's at that lower end, probably even below where we were clearing into that H2 global auction earlier this year. So look, I'll leave it there, and just some final summary here of despite some of the challenges that the market faces, it does continue to develop. The slight worry at the moment is that Europe is lagging behind some of those other regions. Big concern at the moment around that mismatch between FIDs and binding offtake agreements, and still some more work there to do in terms of understanding how to maybe extend the length of some of the contracts that the offtakers are willing to sign up for. And then finally, there's this big question about RFNBO compliant ammonia into the European market. But on the flip side, what we might see is that quite a lot of that uncontracted blue ammonia ending up into the European market as well, because that is a viable alternative to conventional ammonia. So I will stop there. Happy to take any questions.
Sure, thank you so much for sharing. And I got some questions for you. So the first one is, what are your predictions for the second round of the Hydrogen Bank auction, which is scheduled to be reviewed on December 3rd?
Yeah, good question. So I think, our expectation is that we maybe don't expect some of the clearing prices to go quite as low as they did in round one, but we certainly still think that will clear below €1 per kilogram. I think one of the questions we're pondering at the moment is that what we saw in the first round was that some project designed their bids to try and capture 1/3 of the available funding. And I think the question for us is that do we see that same trend, or maybe we just see some smaller projects and more modest projects that are might find it easier to secure some of the off-takers, because we've already seen one of the 7 awarded projects from the first round fall over. The other 6 are I think they're facing challenges, I think it's reasonable to say. So we might see more conservative bids into the auction, probably still below €1. We would also expect it to be similar regions that end up winning, whether that be Iberia or the Nordic markets, where we still have the most competitive project opportunities. Maybe if I had to give an example of a surprise, maybe a project out of Italy that we didn't really see too much activity from in round one might offer a small surprise into the bids.
Thank you for your predictions. And the other question is, what do you anticipate will be the next major area of interest for the investors in the hydrogen or ammonia sector? I
think we spent quite a lot of time this year looking at some of the e-fuel opportunities, whether that be e-methanol, e-methane, e-SAF. I think it's still too early for the market to really invest too heavily into those spaces. There's not quite the maturity we require. Where we probably see a bit more activity is around some of the legacy ammonia terminals. So, you know, as companies are trying to develop ammonia supply capacity to capture export opportunities, what you might see is some of those companies start to look further through the value chain, and maybe we begin to see some acquisition of import terminals, you know, more ship orders for ammonia carriers come through, etc. So I think that's maybe where we expect to see a bit more interest in trying to, some of those major suppliers trying to build positions into the legacy ammonia import facilities.
Well, thanks for answering that, and thank you very much for joining us today.
You're welcome. Thank you.
Thank you. Now, please join me to welcome our next speaker, Ms. Cristina Alonso. She is part of the engineering unit in Spain National Hydrogen Center, and she will give us the latest updates of Hydrogen Valley in Spain. Welcome, Cristina. The stage is yours.
Thank you very much for your introduction. Good morning. I'm going to share my presentation. Can you see it properly?
Yes, we do.
Okay, so I'm going to talk about country spotlights, the role of hydrogen valleys in Spain. First of all, I would like to introduce you the Spanish Hydrogen Center, which is a public R&D organization created in 2007 through a consortium between the national and regional government, 50-50, excuse me. It is located in the center of Spain, in Puerto Llano, Ciudad Real. Our mission and vision is focused on the hydrogen and fuel cells technologies development, covering the whole value chain. Our objectives are to promote and boost the hydrogen and fuel cell technologies, to perform research, demonstration and validation of prototypes and equipment, to develop and scale up processes, and to implement R&D projects, to offer services at national and international level. Let's get into matter. Hydrogen valleys pave the way for the setup of regional mini hydrogen economies by combining or pooling hydrogen supply and demand to increase scale, maximize asset utilization, and bring down cost. Regional integrated hydrogen ecosystems, so-called hydrogen hubs, hydrogen cluster, or hydrogen valleys ecosystem in the different countries. Hydrogen Valley refers to a project or cluster of projects that involves the aggregation of diverse hydrogen production, storage, and utilization technologies and routes within a defined geographical region. Renewable energy is powering an electrolyzer to produce hydrogen, which is stored in its pure form, or converted to a hydrogen derivative. After storage, it is transported to the end user sites via pipelines, trucks, or ships, in its pure form or as a hydrogen carrier. Hydrogen is finally used in the power, mobility, and our industrial sector with the value bundles, but also externally. Some advantages of the hydrogen valley is the creation of employment opportunities in the renewable hydrogen sector, opportunities and hands-on training employees. Environmental and health benefits through the wide creation of with the wide adoption of carbon-free renewable sources, creation of new hydrogen regulatory frames and regulations in hydrogen values, CANAC and testbed. Significant investment and capital expenses saving through infrastructure sharing among the different involved stakeholders. Collocation and synergies among the different actors within the hydrogen value chain, industries, businesses, academic, regional and national authorities, and citizens. Cost competitive of hydrogen production through the economies of scale and cost reduction through the learning curve effect. These are some Spanish policies and legislation that we are going to see later. Here, I would like to show you some example projects from the Mission Innovation Hydrogen Value Platform, which show that hydrogen violence has become a truly global phenomenon. Mission Innovation Hydrogen Value Platform is an exclusive group of leading hydrogen projects who can actively collaborate and exchange best practice. It's a key action step in Mission Innovation goal to reach the milestone of 100 hydrogen valleys by 2030. These are the main references where you can have more information. Now, I would like to show you the different hydrogen value archetypes according to Roland Berger. Archetype 1 is the small scale local mobility center hydrogen valleys, typically from 1 to 10 megawatt of local electrolysis capacity. These projects typically combine the decarbonization effort of various regional mobility fleets, hydrogen fuel cell trucks, buses, trains, and the value then matches the combined demand with the build out of jointly used hydrogen refueling station and centralized clean hydrogen production. They have historically enjoyed sustainable public support, but are now moving to more and more commercial business models.
Sorry, Christina.
Yeah.
Sorry to interrupt, because we have audience to say that the slides are not changing or the slide is fixed. Have you ever drive the
It's
slide?
not changing. Can you see it?
I think we're still in the mission and vision slides.
I will try to share again. In the archetype 2, you would like to go again to the archetype 1? Oh, it's okay. So the first archetype is the smaller scale local mobility center hydrogen vials, typically from 1 up to 10 megawatt of local electrolysis capacity. This project typically combines the decarbonization effort of various regional mobility fleets. The value then matches the combined demand with the build out of jointly uses hydrogen refueling station and centralized clean hydrogen production. These have historically enjoyed sustainable public support, but are now moving to more and more commercial business models. Archetype 2 is the medium-scale hydrogen value focusing on industrial decarbonization, typically from 10 to 300 megawatt of local electrolysis capacity. These values are based on a local or regional hydrogen production source, usually clean hydrogen, directly at the site of one or more large industrial consumers, serving as anchor load, such as refineries or fertilizer production plants. The key to success for such project is a seamless integration of the hydrogen production in the established production processes on the anchor off-taker. This type of hydrogen value continues to grow in numbers and production sizes. The archetype 3 is the large-scale and ultimately export-oriented hydrogen values, typically 250 up to 1,000 megawatt of local electrolysis capacity. This type of value is characterized by focusing on low-cost production of clean hydrogen for local offtake, but ultimately mainly regional and international export to connect supply and demand center on a global scale. According to the European Commission, the hydrogen values division is the large-scale hydrogen values, more than 4,000 tons per year of hydrogen produced and used, and the small-scale values, more than 500 tons per year of hydrogen produced and used. These are some examples of the values around the world in Germany and Netherlands, but we are going to focus to the Spain one. Spain is well placed to take a leading role in growing Europe's next hydrogen economy. Recent costs increase and limited commitments so far for potential off-taking reduce the speed. Spain's ambition of 11 gigawatts of installed electrolysis capacity by 2030 could translate into the annual production of around 1.1 megatons of green hydrogen, requiring a total investment of about 20,000 euros million for electrolysis alone, with additional investment requirement for renewable energy. Green hydrogen could be produced for 4 to 5.5 euros per kilo in Spain by 2030, around 10 to 20% below the projected production costs in Central Europe. Thanks to power purchase agreement markets, the lower cost of electricity, which is key to cost-competitive hydrogen production, as well-established industrial and transport footprint with the potential to drive new hydrogen and synthetic fuel demands. Spain, together with Portugal, is the fifth largest emitter of biogenic CO2 in the European Union. Spain has the potential to retrofit its existing networking of gas pipelines for the transportation of green hydrogen, both for domestic consumption and for export. Spain enjoys an advantageous geographical position to maritime trading routes. Spain could install 15 to 20% of the total European electrolysis capacity target by 2030. Some key challenges for Spain are the European Union and Spain might continue to ensure that regulatory demand for green hydrogen is met, financing first-of-the-kind green hydrogen projects and making them bankable, deploying and optimize the infrastructure to develop green hydrogen production, transport, and store, fostering demand of green hydrogen and derivatives, scaling up green hydrogen production, and ensuring its competitiveness. Spain produced approximately 0.80 million tons of hydrogen in 2022, representing around 10% of the European Union's total production. Most of Spain's current hydrogen production is grey hydrogen. However, efforts are underway to expand green hydrogen production through renewable energy projects. The Spanish government launched support scheme for hydrogen volumes, 1.2 billion euros to support industrial-scale projects based on a set of criteria, including prior commitment from customers to purchase 60% of hydrogen production. Hydrogen must be renewable as per European guidelines. For electrolysis, capacity must be more than 100 megawatt, with an exception for grouping of projects with at least 50 megawatt electrolysis capacities. Several production projects utilizing a cluster approach are already underway in Spain, such as Fertiveria's renewable hydrogen, ammonia and fertilizer production project here in Puerto Llano. Now let's make a quick tour through some of the hydrogen values in Spain. The Basque Hydrogen Corridor, led with the lead developer Petronor, has the object in the creation of a hydrogen ecosystem in the Basque Country which allows progress in the decarbonization of the energy, mobility, different industrial sector, as well as services sector, and is based on a specific project and actions building on a strategy of public-private collaboration. In addition, with the Basque Hydrogen Corridor aims to be a key enabler of sustainable development of the hydrogen energy value chain in the region. The value chain coverage, hydrogen production route, hydrogen in end uses, hydrogen storage conversion, hydrogen transport and distribution. Venor Hydrogen is a multi-user green hydrogen project looking to decarbonize regional industrial energy generation, the gas grid and the mobility sector, included planned development of a dedicated hydrogen distribution grid through the industry valley. The lead developer is Hi5 Hydrogen. The value chain is the primary energy sourcing. Green Island aims to create a replicate hydrogen territory in the Balear Island by covering solar energy generated in Mallorca into green hydrogen, which will be used in multiple applications, mobility, heat and power, and injection into the gas grid. To meet the project goals and balance, a multidisciplinary consortium has been configured, covering the whole value chain in the project and coming from industry, large and small public bodies, research and academy and community organization. The lead developer is Enagás, and the value chain covers primary energy sourcing, hydrogen production, hydrogen storage, hydrogen transport, hydrogen distribution for mobility. Green Crane initiative aims to pave the way for south-north green hydrogen flows in Europe and boosting local demand in Spain and Italy. Cross-border routes aim to connect with the Netherlands and France. The lead developer is Enagás Renewable. Repsol project, Andalusian Green Hydrogen Valley, will install 2 GW of electrolysis capacity in Huelva. Onuba project is an agreement with Fertiberia to produce 400 MW of renewable hydrogen and ammonia with a direct power supply agreement and agreement with T2X to produce 200 MW of renewable hydrogen and renewable methanol. In Cartella, they will produce renewable hydrogen with EDP and renewable ammonia with Yara to decarbonize industries and the maritime sector, also in the Central Europe. The value chain covers primary energy sources, hydrogen production, hydrogen store, hydrogen transport, hydrogen distribution for mobility. The Valencian Hydrogen Cluster, HyVal, is an initiative led by BP created with the aim of promoting and favoring the development of the renewable hydrogen economy in the Valencian community and contributing to the region's energy transition through public-private collaboration. HyVal to include large-scale green hydrogen production at BP's Castellón refinery of up to 2 GW of electrolysis capacity by 2030 in 2 phases. Orange Bat consists on an electrolysis of 100 MW to produce green hydrogen in the municipality of Onda, Valencia, under hydrogen purchase agreement to industrial off-takers, ceramic cluster, and for mobility. The hydrogen will be distributed through a new hydrogen grid. The green electricity required will be provided by PPAs from renewable energy plants. They partner with leading technology players in the hydrogen industry and other European Union equipment suppliers. The lead developer is Smart Energy. The value chain covers primary energy sourcing, hydrogen production, hydrogen store, hydrogen transportation, hydrogen distribution for mobility. And to conclude, I would like to highlight that the European Union continues to support hydrogen production through the first European-wide renewable hydrogen action science grant agreements with 6 new projects, 2 of them here in Spain, Hisensia and Catalina, where CNH2 will participate. Thank you very much for your attention.
Thank you for sharing your important information with us, Christina. I have also gathered some questions for you. The first one is, how is Spain Hydrogen Valley planning to drive the commercialization of hydrogen? And what specific end user or applications are being prioritized for adoption?
Spain is leveraging its hydrogen values, including key projects like those in Aragon, Castilla-La Mancha, and Catalonia, to drive the commercialization of green hydrogen. These initiatives are part of the European push to develop hydrogen technologies under the European Hydrogen Strategy, which aims to achieve climate neutrality by 2050. Spain's approach focuses on several key strategies, industries and application, priority end users, and hydrogen values as pilots.
Thank you for your answer. And the other one is, would you please estimate how long it might take for a mature and sustainable business model for green hydrogen to fully develop or reach commercial viability?
Achieving a mature and sustainable business model for green hydrogen depends on overcoming several technological and economic challenges. An estimation based on current European Union's plans and hydrogen adoption trends have short-term, from 2024 to 2030, development of hydrogen production and distribution infrastructure, especially electrolyzers and pipelines, gradually cost reduction of electrolyzer through scaling and innovation target from 2 to 3 per kilo for hydrogen. A medium term, 2030, 2040, have the market penetration in additional sector, including aviation and residential heating, and developing international hydrogen trade routes. And the long term, 2040, 2050, full commercial viability, with production drops below 1.50 dollars per kilo. These timelines align with the European Union's 2030 climate target plan and the 2050 climate neutrality goal.
Thank you so much for answering. And there's also questions for you in the Q&A box. And if we would appreciate if you could stay a little bit longer and then type your answer in the Q&A box. Thank you so much. We're happy to have you here today.
Thank you very much.
And now it comes to our next session. Let's welcome Ms. Julieta Madrasca, who is the Senior Hydrogen Commercial Strategy Manager from Repsol. In her presentation, we can hear what is Repsol's strategies under this challenging moment of hydrogen development. Welcome, Julieta.
Hello. Sorry, hello, can you hear me? Yeah.
I can hear
Hello.
you.
Good morning, and thank you for having me. I start sharing, let me share my presentation. Good morning, sorry for this error, this mistake. It's an honor to be here today. Thank you for having me. I will share with you why Repsol is committed to decarbonization, particularly in this keynote, with the focus on the industrial sector, as well as outline our strategic path in renewable hydrogen. I will begin by presenting my company, Repsol. We are an energy company committed to a sustainable world. Repsol is a global multi-energy company leader in the Iberia Peninsula that can meet all its customers' energy needs domestically and on the move. It employs 25,000 people in over 20 countries and serves 24 million customers. And it was the first in the industry to commit the net zero emission by 2050. We are, our net zero goals cover not only the emission from our production, but also those from the use of our products. And for this purpose, we have set intermediate targets on our roadmap for 2025, 2030, and 2040. In this period, the best way to boost competitiveness is, without a doubt, support technological neutrality, allowing technologies to compete the lower our energy carbon footprint and the smallest possible cost, because it will have a cost. Electrification is not enough by itself. Electrification is not the same as decarbonization, and we need to have other options such as biofuels, synthetic fuels, recycled materials, and of course, renewable hydrogen. Repsol produced energy from different sources, including hydrocarbon, renewable energy such as wind, floating wind, solar, and hydroelectric, and transformed it into products and services for our customers. Repsol has 4 main business lines that enable it to move forward in the energy transition: upstreams, industrial, customers, and low carbon generation. I want to share with you some big numbers regarding our footprint and capability. Our industrial operations are robust, and we have implemented over 650 digital transformation initiatives and established the Repsol Tech Lab, which boasts over 200 research alliances worldwide. Repsol is also a leader in renewable energy, with around 3 gigawatts of low carbon generation capacity in Spain, the USA, Chile, Italy, and Portugal. Going back to the industrial area, we are transforming our industrial facilities into multi-energy hubs, capable of turning a wide variety of raw material and waste into products with a low carbon footprint, such as 100 renewable fuels. Where do we do it? In our 7 industrial complexes, 6 on the Iberia Peninsula and 1 in Peru. The company is proud to have one of the Europe's most efficient refining systems, capable of processing over 1 million barrels of crude per day. Our industrial strategic line 24 to 27 aim to increase the profitability and create hubs for renewable fuels. We will advance in turning our industrial complexes into low carbon platforms, becoming leaders in the renewable fuels in Iberia, and explore opportunity to grow our renewable fuel businesses in more attractive markets like the USA. We are transforming our legacy sites. In the value chain, we have made conventional and renewable valuable fuels and biomethane from organics and plastic waste, feedstock, circular material, and now we are incorporating also renewable hydrogen. I want to highlight Repsol's commitment to innovation and technology throughout our Repsol Deep Tech Fund. This fund is endowed with 50 million euros for investment and startups, and we have already invested in 20 startups with disruptive technologies. We have over 230 experts working in various fields such as advanced mobility, bioenergy, advanced mathematics, geophysics, low emission, and of course, renewable hydrogen. Our Repsol Technology Lab is a hub of innovation. Repsol has a strong ambition to remain leader in hydrogen in the Iberia Peninsula. Our goal aligns with the US stated in REPowerEU, which plans to produce 10 million tons of renewable hydrogen and import another 10 million tons within the EU by 2030. And our renewable hydrogen is a fundamental lever in our decarbonization strategy. We are planning to install electrolyzer capacity in our refineries to gain practical experience and achieving scalability, and aim to leverage Repsol's industrial experience and partnership capabilities to maximize our strengths. Repsol will leverage its own platform as the first hydrogen producer and consumers in Spain, and its presence along the value chain, renewable generation, hydrogen production, and commercialization. And our plan is not restricted to our own consumption, need to include growing our leadership in hydrogen production to meet the demand to other clients, such as industrial consumers like fertilizers, steel, and chemicals in clusters near our industrial sites, which we will reach with short-distance logistics. Heat uses, initially blending hydrogen with natural gas in the Spanish natural gas network, and serving emerging needs of hydrogen and e-fuel in transport. Our vision for hydrogen deployment is both strategic and feasible. We are aiming to install up to 0.7 gigawatts of hydrogen capacity by 2027 and up to 2.4 gigawatts by 2030, including our international position and renewable hydrogen generation from biomethane. Targets and capex could be adapted according to opportunities driven by regulation and market development. Here you can see the Repsol Hydrogen Hub development in phase 1 until 2027. There are ongoing big projects across Iberia with a multi-production technology approach. Some of them, for example, Tarragona, 150 megawatts, Cartagena, Bilbao, the big ones of 100 megawatts, Puerto Llano and La Coruña, 30 megawatts, and in Sines, Portugal, we have a project with 4 megawatts of electrolyzer. For all these projects, we are planning operations in 2025, 2026, and 2027, depending on the regulation and tax scenario. Here you can see the Repsol Hydrogen Hub development in phase 1, and Bilbao. I can move this. Here are some cases I want to show you. Bilbao project is a key part of the Basque region strategy to become a significant energy and transport connection hub between Spain, France, and the European Union. In this site, we have 3 electrolyzers. The first of 2.5 megawatts is in operation from last year with an annual production capacity of 350 tons annually of renewable hydrogen for industrial and mobility uses. The second one of 10 megawatts with our partner Saudi Aramco, it will produce hydrogen for the refinery and for an e-fueled plant, which will also use capture CO2. And the biggest, 100 megawatts, to use the product not only for the refinery, but also for injection into the natural gas network. Its planned operation is in 2027, and this project has been identified by the European Commission as a project of common European interest. A 100 megawatt project is underway in Cartagena too. The HyNet project can integrate renewable hydrogen into the development systems of interconnection between the Iberia Peninsula and Central Europe. We aim to produce renewable hydrogen and oxygen in the Cartagena refinery in the Escombrera Valley. We are in the front engineer design this moment, and the FID should be in 2025, next year. As the 100 Petronor project, this project is also identified by the European Commission as project of common European interest. As Cristina said before, it's also important to mention that Repsol leads and promotes hydrogen valleys in Spain, such as the Basque Hydrogen Corridor, the Hydrogen Valley of Catalonia, the Hydrogen Valley of the region of Murcia, among others, in line with the future hydrogen backbone network. And it participates as a promoter company in the collaborative alliance SHINE, Spanish Hydrogen Network, created in 2022, with the mission of promoting renewable hydrogen and maximizing the entire value chain. This association has a collaborative network made up 7 promoter companies and more than 20 collaborators. It's important to highlight the basics of the industry in the context of the energy transition. Decarbonization is not possible without industry. And as Brandon said, sustainability is everything that allows us to meet our current needs without compromising the ability of future generations to meet theirs. To conclude, Repsol remains optimistic. The company is confident in its current renewable hydrogen portfolio, which enables it to capitalize its diverse efforts in the unique condition of the Iberia Peninsula in terms of renewable resources and industrial synergies. The advancement of European and Iberia Hydrogen Initiative can build upon Repsol existing flagship projects, lowering barriers for new investments both in the peninsula and internationally.
Thank you for your sharing. Thank you so much, Julieta. I've also got some interesting questions for you. So the first one is, in your view, what are the primary challenges or barriers to scaling hydrogen adoption in the coming years? And what strategies might address these concerns effectively?
There are many challenges to expanding the use of hydrogen in the coming years regarding technology, regulation, and infrastructure, among others. But I would like to highlight three in particular. The primary concern is the high LCOH, the levelized cost of hydrogen production, influenced by the capex of electrolyzer and electricity prices, making economic viable without subsidy difficult at present. Funding from European and national sources is essential for market creation. In the case, for example, of hydrogen in particular, electrolysis technology has been known for decades, but has not yet been operated for long periods at the scale of which 100 megawatts plants are now being planned. Second, all elements of the value chain need to be stimulated. Not only are incentives need to launch production projects, such as the hydrogen bank action, but also mechanisms to stimulate demand that will drive new investments and promote the creation of a liquid and competitive market. And finally, it is essential to establish a stable and favorable regulatory and administrative framework for decarbonization, creating the long-term certainty that is crucial for the development of capital-intensive initiatives, to attract investors and to harmonize the different actors in the value chain. Developing a decarbonization economy with hydrogen will be challenges. However, well, as I said before, Repsol remain committed to sustainable energy security, and achieving net zero emissions by 2050, sorry.
Thank you so much for your answer. And I just saw a question raised up by our audience, Arthur. So he asked, how do you see e-fuels playing a role in your future fuel product portfolio? Do you see that e-fuels can reach price parity without government subsidies with traditional fossil fuels?
Yes, the subsidies is something that is fundamental in this moment. The e-fuels could be a way, a path to decarbonize our process, our industry. Then we are assessing and evaluating some other projects for e-fuels, also from Repsol, and know now, because we need more some other leverage to improve the rentability for this project, but we are giving our first steps with the project, for example, of 10 megawatts in Petronor that I said before. One of the main uses of this hydrogen is to produce e-fuels. We believe in this, and we are in the path to use the e-fuel as one of lever more in our industry. Sure.
Thank you so much for answering, for your time. Hope to see you in Impact Webinar next time.
Thank you. Thank you very much.
Now we come to our final topic for the webinar, Ms. Aurora Pasi-Lagrada, who is the Business Development Director at Nel Hydrogen. Today, she will address topics about hydrogen solutions, which we received numerous questions about hydrogen technology. Welcome to the stage, Aurora.
Hello, good morning. Thank you for having me in this webinar. I will start sharing my screen first.
Sure, thank you so much.
Can you see it now?
Yes, we can see it perfectly.
Okay. So as per my introduction, I always like to start with this picture you can see here. This is an old Nels alkaline plant from early the 20th century, located in Rjukan, Norway. At the time, it had 6 floors, as you can see in the picture. And when Norway came under German occupation during the Second World War, the production of hydrogen for heavy water was destroyed. If anyone is interested in knowing the full story, I'm very happy to provide it. Anyways, this picture really shows that the technology was already proven, and what we are seeing now coming are new applications. A little bit further than that, I like to talk about Nell's history because we have been basically producing electrolyzers for almost a century now. We started with Norsk Hydro and built the two largest plants ever built, both in Norway. And we have used that technology legacy for over the years. Obviously, the technology has improved, but the fundamentals are the same. The electrode manufacturer facility is in Eroya, Norway, and it has a current 1 gigawatt annual capacity, and it's fully automated, as you can see in the picture. And then in the US, we have in Wallingford, Connecticut, we have another technology that has been developing and selling for 27 years now. This one started with proton on site that originally utilized PEM technology to produce oxygen for submarine life support. And now, over the last years, in collaboration with General Motors, we are developing the next generation PEM technology, which will improve price performance and efficiency. Indeed, the last month we have the grand opening in Wallingford, Connecticut, and now the production capacity is 500 megawatts, mostly automated. Talking about markets and applications, green hydrogen is becoming a must for companies that are hard to electrify. While some companies and industries can easily decarbonize by switching to clean electricity, others, such the ones we see here, refinery, ammonia, methanol, different transportations, must use renewable hydrogen to end their dependency on fossil fuels. So in the next one, just as an example, we have steel. Globally, steel industry is among the 3 largest contributors to CO2, responsible for 7 to 8 of the total emissions. So imagine how huge opportunity for green hydrogen this is. And the next slide talks about what a large opportunity it is. So for giving perspective, this purple dot you see in the slide is basically the size of our factory expansion in Wallingford. If we look to a couple of potential off-takers as ammonia and steel, the size of our facility expansion is many times the size of our expansion. So that market stock where we are selling into it has the opportunity to go well beyond that. In fact, there are a lot of studies on green hydrogen market and how quickly it's going to evolve. This one is one that I like from the Boston Consulting Group and talks about over the next 10 years, how does the green hydrogen market going to grow, but not in terms of just green hydrogen per se as an end product, but also the derivative molecules that uses hydrogen as input, as ammonia, kerosene, and other synthetic hydrocarbons. So what data shows is that over the next 10 years, 24% growth is a realistic growth. And all studies that we are reviewing and seeing point at the significant growth over the next years as well, as my other colleagues have shared previously. In the next slides, I want to touch on a few pictures of installation examples to show how a relevant scale electrolyzer plant looks like and what we are offering in terms of large plant concepts. So it is important to mention that multi-megawatt plants are built and operational. Here you can see a couple of examples. On the left side, it's a 20 megawatts alkaline plant, and on the right side, you can see a 20 megawatt PEM plant. I will give you some more specific on these ones later. For mobility applications, we have installed a number of packaged PEM electrolyzer plants, as the one that you see in the picture. This is a fully integrated solution that sizes very well for a lot of car, truck, bus, fueling application. This is just an example located in Switzerland of 2.5 megawatt nominal power and about 1.1 metric tons per day. We move to another example that it's the famous one and the one that mentioned before. It's the largest PEM electrolyzer installation installed to date, which produces 8.5 metric tons per day of hydrogen output. And this is used for green ammonia production at the Fertiberia plant in Puerto Llano, Spain. Another case is Ovako in Sweden. This case is for producing green steel with 20 megawatts of alkaline electrolyzer and 8.4 metric tons of hydrogen. And lastly, another case. This one is Everfuel. It's 20 megawatts as well. And in this case, it's for a combination of mobility and refinery decarbonization. And just to address larger scale designs, we are working with EPC companies on doing full plant designs for both our technology platforms. We have 100 megawatt concepts designed to bring our core technology to the market. I'm sorry. So left side, you can see the alkaline design. It's a 100 megawatt design with an Italian EPC company called Saipem. And on the right one, it's another 100 megawatt PEM plant developed on our own with an engineering partner. So a couple of more slides about what we are focusing, that is to offer the lowest cost production for both our PEM and alkaline platforms. Our next generation alkaline technology is going to be pressurized, and on the PEM side, in collaboration with GM, is also going to offer improvements in efficiency and cost. And on the cost side, we will be going between 40–70% CapEx reduction on our electrolyzer stack cost. These two topics are very important to us. And here you can see the prototype that we are developing for the pressurized alkaline. It is TRL5 with 25 megawatts and 15 bars pressure. And this last slide shows that we are focusing on what we do the best. That is our core technology. You can see in the purple rectangle. That is the stack itself and balance of a stack. Because at the end, the balance of the plant is something that can be done by others with the help, of course, of Nels design. As we want to get to standardized deliveries and less customization, as we think that this is how we can really drive cost out of the technology. And in terms of market focus is on areas where demand is very high, the ones you see in purple as well, as Europe and North America. And as export markets, we are focusing in Australia and Chile. And that would be all from my side.
Thank you. It is a brilliant presentation. And then there are also some questions for you as well. So the first one is, what is your opinion of alkaline technology? Like what advancements and innovations can we expect in alkaline tech over the next few years?
So we have both technologies, alkaline and PEM. We see alkaline technology as one of the most mature and cost-effective technologies for the green hydrogen production. It is also very reliable, and it works very well for large-scale hydrogen applications. So at NEL, we believe that alkaline technology will remain a cornerstone of the hydrogen economy, especially for industrial applications that require robust and proven systems. And the second question, just looking ahead, the innovations that we can expect in alkaline would be the one that I saw, the pressurized alkaline, as our next generation. But also, we are not stopping our current product lines. So in that line, we also see efficiency improvements, operational flexibility, more modularity, and cost reduction in our current atmospheric line. Yes.
Yes, so how does Nel Hydrogen see its role in accelerating the global adoption of green hydrogen? And what are the key markets or industries you are prioritizing for the growth?
So Nel's mission is to empower industries and communities with sustainable hydrogen solutions. We are very committed to scaling up green hydrogen production, especially reducing cost. And regarding the key industries that we are seeing, it could be ammonia production for fertilizers, then transportation, especially for heavy-duty applications, like buses, trucks, and shipping. And then we also see green steel manufacturing and methanol production.
Thank you for your answer. And I just saw one question raised up by our audience. So he would like to know how our current hydrogen project is in arid or water-stressed areas addressing the dual challenges of water scarcity and the need for ultra-pure water quality for electrolysis. It's raised up in the Q&A box.
So the majority of the projects that we are seeing are in Europe.
Okay. Well, thank you for sharing your thoughts and also appreciate your join today.
Thank you. Thank you for having me.
Now all the speakers have presented. We come to the end of the Impact webinar. Once again, a big thank you to all our esteemed speakers for sharing their invaluable thoughts. And to our audience questions, attention, and participation. Today's recording will be posted on our official LinkedIn page and YouTube channels by next Wednesday, along with critical takeaways from this webinar. For further inquiries, please do not hesitate to contact me at cecily@leaderassociates.com. I want to remind you once again that this webinar serves as a virtual pre-event for our Connecting Hydrogen Europe 2025 in Madrid next June. We hope to see you there and explore the development and application for hydrogen together. Let's work together for a brighter and a cleaner future. See you next time and have a wonderful day.